Assalamu alaikum, dear students. I am Mr Fayaz Ahmad kuchay from Baramulla. I am being posted at Ashpura High Secondary Kupara. Today my topic is for class 11th electronic students. The topic is current division theorem. Dear students, you may be aware that I have already given a lecture on resistors in series and resistors in parallel. You may be knowing that when we connect resistors in parallel, current is being divided. Current is being taken in divisions, that means in parts, which means you are writing for current. There, when you are taking parallel type of resistors connected, we are connecting resistors in parallel to each other. This R1 is connected parallel to R2. So when you are connecting these resistors in parallel fashion, you are taking current in divisions. That means you are writing. You check there where I have shown you the resistors connected in parallel. There we are writing I is equal to, in divisions, I1 plus I2 plus I2 plus I3 so on. जितने भी how many resistors there we may connect in parallel type, those resistors are being taken in division. That means they are being separated in divisions. We are taking I1 plus I2 plus I3 so on. So here is the same case. When you are taking current division theorem rule, we can say it as a rule or a theorem. You have to take, when you are taking it as a theorem, you have to take the current I1 is flowing here. This is your current source here, current source. For example, this is of 2 ampere. Current is being measured in amperes. For example, this is a current source being of 2 amperes. So you have to show what's the value of I1, I2. You have got the relation for I1. How will you find out the value of I1? That you have to take equal to R2 divided by R1 plus R2 into current source, the value of current source. Similarly, you have to find I2. You will give the value R1 by R2 plus R1 into current source. The formula is I is equal to I1 plus I2 plus I3, which we are using there in resistors being connected in parallel type. So dear, when you will get I1 and I2, on adding them here, that should be equal to I1. That should be equal to I, that is 2 ampere. So I will give some particular values to here, and then adding those values like this, I is equal to I1 plus I2 plus I3, then that value should be equal to 2 ampere. For example, this is your 2 ohms resistor and this is your 4 ohm resistor. This is 4 ohm and this is 2 ohm resistor. How will you get the values? You see, check it. I1 will be equal to R2. R2 is here. R2, I1. That value, you see, current I1 is actually flowing from this resistor. But here you have to take R2 from where the current does not flow. That is 4. 4 you are writing here. 4 divided by R1 from which the current is flowing, 2 plus R2 from why it doesn't flow, that's 4 into current source, that's 2 ampere, that's 2. Its value will be equal to 4 by 6 into 2. You simplify it, it will get 2 1 is 2, 2 3 is 6, that's equal to 4 by 3. 4 by 3. For this, you are getting, you see again, R2's value is 4, R1's value is 2, plus R2's value is 4 again. This is 6 into 2. 2 ones are 2, 2 threes are 6. That is now 4 by 3 ampere. You are finding the current. That's why I am writing here 4 by 3 ampere. Similarly, you have I2. I2 is equal to I2. For I2 you have the formula R1 that is 2 divided by R2. What's R2? R2 is 4 plus R1 that is 2 into current source that is 2 will be equal to 2 by 6 into 2. 2 ones are 2, 2 threes are 6. That will be equal to 2 by 3 ampere. This is your I2. But the formula is here given to us that I have shown to you, that's equal to I is equal to I1 plus I2. I is equal to I1 plus I2. Here you have got only two resistors, R1 and R2. So you are adding these two. I1 is equal to 4 by 3 plus I2 is equal to 2 by 3. So this will be equal to 3. This is 6, so is equal to 3 1 is 3, 3 2 is 6. I will be equal to 2 ampere. I is equal to 2 ampere, which is given here. That means our supposition was correct. So this is the way, this is the rule, how you are dividing the current, how you are bifurcating the current. That is I is equal to I1 plus I2 plus I3. Bifurcating the current when the current being given to a particular circuit. So this was your current division rule, or you can say Theorem. When you are being asked to discuss about current division Theorem, you have to write this thing there. I1 is, you have to draw a similar circuit, R1 R2. Then you have to show I1 is equal to R2 by R1 plus R2 into current source. Similarly, R2 is equal to R1 by R1. Then you have to show, in case of resistors connected in parallel, you have to show I is equal to I1 plus I2 plus I3, as I have shown in there. You may have also read it in class 10th also. When we connected resistors in parallel, we will have I is equal to I1. The current is being bifurcated, taken in divisions there. So that's why I am taking it in divisions. I is equal to I1 plus I2 plus I3. So we are getting the value of I1. I1 will be equal to this formula you are putting, that's equal to 4 by 3, but I2 will be equal to 2 by 3. This we are simplifying. I is equal to, putting the formula here, you will have I is equal to 2 ampere, which is given to you 2 ampere. That means our supposition was correct, our theorem is correct, the rule which you are implementing here is correct. So that will do for today. This was the current division theorem or rule, how to find the current in a circuit, current I1, I2 in a circuit. I have shown you clearly. I am sure that you may have got it. How was the method of current division theorem. Okay, see you. Assalamu alaikum.